To introduce the strategy pattern, let's take a look at this vehicle here called a Viking. Now, if you watch how the vehicle moves around, you'll see that if I start clicking, he'll fly from point to point. Now, if I want to change how he moves, I can switch into a different mode called assault mode. And then when I click somewhere, he'll start walking. So you can basically change how he moves while you're playing the game by switching between these two modes. Between fighter mode, where he'll fly around the screen, so the way that he moves is flying, and then back to assault mode, where he will walk around the screen, so the way that he moves is walking. So let's talk about how the strategy pattern relates to changing a behavior while your program is running. For example, changing the way that he moves from flying to walking. The only way to learn about a design pattern is to learn the problem that it solves. So design patterns are created to address these problems you'll run into in your code, in your day-to-day coding. And this little example will show you the problem and show you how the strategy pattern solves that problem. Now, this example shows in the constructor, here I'm just creating a Viking, which is a sprite, setting flying to true, setting his position, adding him to the stage. And when you hit the keyboard 1 key, it'll set flying to true. When you hit keyboard 2, it'll set flying to false. And then when you click, if he's flying as true, it'll do this tween. Or if flying is false, meaning that he's walking, it'll do this tween here. Now, if we run this, you can see that this already works pretty well. So if right now flying is true, so he's flying around. If I hit 2, now flying is false, and he's walking around. 1, fly, 2, walk. Now, the first thing we can do, just to do some general cleanup here, is to give the Viking its own class, so that we can put this graphics stuff into the Viking class. Put the move method, or add a move method to the Viking, because when you click, you want to tell the Viking to move. So let's look at that real quick here. I'll create this Viking class, put it in a PatternCraft strategy package, and because he extends sprite before, or it was a sprite before, now it should extend sprite. And we're going to grab some of this graphics code, go to the Viking, cut that. So now the graphics is in the Viking class, and we're also going to where we click, in the on-mouse click, all this stuff should really go into telling the Viking to move. So let's Control X that to cut it, and we'll say Viking move, and we'll pass in the tween vars. And we'll create this method, the move method, and paste that in there. Add the few imports. Since this is actually in the Viking class now, we can say this, and the last thing that's missing is the isFlying value, and we can create the isFlying field, which is a Boolean, and we'll actually have to expose this. We can get rid of this isFlying, and, whoops, not that one. Go into the strategy pattern demo, and go to this isFlying. Delete that. isFlying's true. All right, so now everything is in the Viking class. whoops, Viking. So this is cleaned up a little bit. Now the Viking is in its own class. Flying is set to true on the Viking. And whenever you click, instead of having that big if-else block, we move that if-else block into the move method of the Viking. And it also is flying, does the drawing, and the move is all in the Viking class. So now we can reuse this class somewhere else. And actually, let's do one extra thing. I'll go into more detail of why we're doing this a little bit later. Let's extract this into a superclass as well, and move all of this into a, let's call it a vehicle class. So now the Viking only has its drawing, what it looks like, and it extends vehicle, which will have the move logic within it. Basically, later on, we're going to create some more vehicles, and they're all going to share this same move method, but they're going to look different, so they'll have a different fill. So now our code looks pretty good, and it works. It still works fine. If I compile it, you'll see you can still click around. Everything's fine and dandy. You still can walk, based on whether you click one or two. Now, the only thing, the only constant in life is change. So, for example, requirements change all the time. Now, imagine if someone came up to you and said, it's great that the Viking, when he moves, he can fly and that he can walk. But the new requirement that you have to meet is that when you hit the keyboard 3, our Viking is going to have to swim. So think about how big of a problem this is now with the way the move is currently set up. Because right now, if we look in our vehicle class, all we do is check between whether or not it's flying or whether or not it's flying. If it's flying, it does this. If not, it does that. If we throw is swimming into here, we're going to have to check if is swimming or is flying, or, we're going to have to check all those different properties. I guess, maybe you've done it where you've set up a switch case and gone between switch and if the case is flying or walking or swimming. There's all these different ways to just add tons and tons of code into this move method. I mean, think about if the new requirement is once you hit keyboard 4, now you have to teleport. Now it just turns into a huge mess, and you have to account for all these different behaviors just to change the way that your vehicle moves. So let's comment this out here real quick and show you how the strategy pattern can solve this problem for you. Now, going back to the vehicle, we can see that the things that are different here are in the if statement. This is our flying behavior. Now, the cool thing we can do here is if I cut this, create a new ActionScript class called fly, create a method here called move, and then paste, let me clean up the imports, format that, and paste this functionality into the move method. Now we can kind of delegate or hand off the responsibility of moving the vehicle into this fly class. Let's do a couple things here. This will actually be our vehicle instead of, it's not this anymore because the fly class is actually going to make the vehicle move. So we'll put him as a parameter. And the tween vars will be our second parameter. And let's make this a vehicle. So this is this is pretty cool. I mean, how this looks perfect, right? Now we have a fly class that has the fly behavior in it, and we can also the quickest way to do this is just to go over to project view, go copy, paste, and we'll create a new, instead of fly, this time it'll be walk. Now we have a walk class with the exact same setup. I'll go into the vehicle, I'll grab this walking behavior, I'll cut that, jump back over to walk, and paste the walk in there, format it. So now we have the walking behavior in one class and the flying behavior in another class. The trick here is how we're going to make this work with the vehicle. The way we're going to do this is creating an interface that the vehicle can hook into and then you can assign either fly or walk or any other behavior into that property on the vehicle. So let's create an interface from this. I'm going to use a little trick here called extracting an interface. Click the check mark because we want to move into the interface, and we'll call this an iMove behavior. Since it can only take a vehicle, we'll call it iMove vehicle behavior. Hit refactor, and now you'll see our iMove vehicle behavior forces anything that implements it to have a function called move, which takes a vehicle and tween vars. So our walk or our fly already implements it, and let's make sure that our walk implements it. Implements iMove, whoops, behavior, iMove vehicle behavior. And now if we go back to our vehicle, we're not going to need this anymore, and we're actually just going to give this a something called a move behavior. And this will be an iMove vehicle behavior. Now when you call move, this is where the magic happens. We're going to say move behavior, move this, and tween vars. Clean that up. So now our vehicle, all it has is this move behavior, and when you call move on the vehicle, it is going to tell whatever behavior you give it, whether that behavior is fly or walk. It's going to call that action, pass in the vehicle and the tween vars into that class, and say, hey, class, you take care of this move because it's too complicated for me to switch between all this logic. So really all we have to do now here is on our Viking, instead of saying is flying as true and false, we can just say move behavior. It's a new fly. And we can say move behavior is a new walk. And that's all we had to do. We still just call Viking move, pass in the tween vars, and we have to give it a default value here. We'll say new fly. And so just to recap again, whenever you hit the key 1, now we're just going to switch the behavior to fly. Whenever you hit key 2, we're going to switch the behavior to walk. So if we compile now, it's going to do the exact same thing that we did the very first time we ran the code when it was all in one class. So when you click around, it's going to fly. If I hit 2, I have an error in my walk class. Let's see what it is. It's not this. We want the vehicle. That's because I copy and pasted it earlier. So now it should be able to walk. So fly, fly, walk, walk. And now here's where the magic is going to happen. if I create another one of these behaviors, let's just go new ActionScript class, and we create our new swim, we can actually just, whoops, get rid of that. Make sure that swim implements the iMoveVehicle behavior, and say implement its methods. We can come in here and write whatever we want within this move behavior. And whenever you tell the vehicle to move, if the move behavior is set to swim, it'll do this type of move. I actually have a cheat sheet of a swim type of tween that I already set up before. So I'm just going to copy and paste that in here. Make sure that this is set to vehicle. So now in our strategy pattern in our main class, I can uncomment these, and whenever I hit the keyboard 3, it's going to set the behavior to a new swim. So fly, walk, swim. Compile. So 1, we're flying, 2, we're walking, and 3, we're swimming. Now this is where design patterns are really cool, is that you may think it's super complicated, but it makes your life easier. It makes code cleaner, and it makes code more readable. For example, let's just create a new move behavior here. We'll call this one a new teleport. We'll create a new teleport class in our PatternCraft strategy package. Teleport has to implement the iMoveVehicle behavior interface. So whenever you call this, you can write whatever custom moving logic you want within teleport. I'm going to grab my teleport from my cheat sheet. It's just a tween of 0. Vehicle. So now whenever you go hit the keyboard 4 key, it's going to teleport. Click, move. So moving is flying, moving is walking, moving is swimming, and moving is teleporting. Should probably added some fade in, fade out, or some cool noise for that, but whatever. So this is, can you see how much easier this is? Just, assigning a fly, a walk, a swim to its behavior. Now whenever you call move, it's going to delegate to its move behavior that you set it to, and that's going to handle the responsibility of walking, flying, etc., etc. Now the added bonus, because we created that vehicle class, is that I can actually come in here and instead of having this Viking, let's say I wanted to create another unit within StarCraft is a Raven. So if I create a Raven class, and we'll put this in our PatternCraft strategy, Raven, and our Raven class, all he has to do is extend the vehicle, and then we can let's hop back over to our Viking class, grab the draw, and make him a different color. And do something like, let's make him a square this time. So now the Raven is a green square, whereas the Viking was a red rectangle. So I head back over here. I'll just rename this real quick. So now we have a Raven which can use these exact same behaviors because the Raven is a vehicle and all of these behaviors can act on the vehicle. and you'll see real quickly that the raven is flying, the raven is walking, the raven is moving, and the raven is teleporting by hitting the 1, 2, and 3, 4 keys. So that's the strategy pattern in a nutshell. Basically, it lets you change a behavior, change an algorithm, change a function at runtime or while your Swift is running. And that's the problem that it solves is cleaning up how you do that. If you've read some other design pattern books, just as a note on the end there, or for the video for other people who've already read about the strategy pattern, you see that it also solves a problem where if you would have written the Viking class and written a fly method and a walk and a swim and a teleport within the Viking class or in the vehicle class, and then extended vehicle and overridden all those methods in the Viking, that it would have become really burdensome, because the Viking doesn't swim or teleport. You'd have to override them and, put in like null logic and all this stuff. It just shows how inflexible inheritance is versus this is, composition, creating objects and passing them into the vehicles. So just that's probably what you've seen as the solution for, or the problem that strategy pattern really addresses. I think this is another good example of a way that it can help you in your day-to-day code, and hopefully this has helped you learn more about the strategy pattern.